Now let's talk about the instruments that are used to measure the data that's collected. The instruments used to implement the data collection can play an important role in the internal validity of the study. A problem that can arise here is measurement error. For example, suppose some of the participants in the data scientists wearing bow ties study happen to be wearing unicorn masks. The individual conducting the data collection was distracted by these masks and didn't properly account for the correct number of bow ties. Rather than counting 5 that were in the sample, they only counted 2, suggesting that only 13% of data scientists wear bow ties. In this case, the measurement error was particularly bad because it only affected how the data collector counted the bow tie wearing data scientists. If instead both data scientists wearing bow ties and those not had confusing unicorn masks, it may not have been as much of a problem. Now the data collector measured 2 out of 7 data scientists wearing bow ties, or 29%, getting a similar result as the properly measured 5 out of 18, or 28%. The difference here is based on whether the added factor, in this case or example, the unicorn masks, is associated with both whether the data scientists are wearing bow ties and how the data collector perceives this. This relationship is called confounding, and we will discuss this in the next section. Let's look at a real example from the literature. Here's a systematic review of the prevalence of schizophrenia. You can find the full text of this article in PLOS Medicine. The study sought to quantify the prevalence of schizophrenia by combining data from studies published from 1965 to 2002. The problem? Some of these studies that were included in the analyses may have suffered from measurement error. In a letter to the editor, it was suggested that some of the studies that were included in the systematic review included patients who later would have been found to have secondary schizophrenia. In other words, they would have been false positives. These false positives could be inflating the prevalence numbers suggested in the original article. You can find this letter also in PLOS Medicine. To this, the authors replied, "The inappropriate inclusion of false positives is only one of a very long list of methodologic factors that contribute to imprecision in the estimation of the incidence and prevalence of schizophrenia. The critical issue for the research community is how best to partition out measurement error from true variations in the incidence or prevalence of schizophrenia. In the absence of more refined phenotypes for the many different disorders that contribute to the syndrome of schizophrenia, e.g., by the use of yet to be identified biomarkers, standard epidemiologic studies of the incidence and prevalence of schizophrenia may have reached their limits of precision. This example highlights both the potential impact of measurement error, as well as the ubiquitous nature of it in the medical literature. When evaluating any claim, it is important to consider how much of an issue like measurement error may be confounding the result." This response is also in PLOS Medicine.